So actually, I have my experience with machine learning and AI for quite some time. My first machine learning model I was running, and my first neural network I was writing in 2002 when in the university. And then I went to different companies and works and jobs. And recently, the last 4.5 years, I'm actually working on AI projects in Microsoft Central and Eastern Europe, covering the product marketing for everything which is related to Microsoft AI. And I would like to start my discussion today with actually a story, or maybe first with this slide, which shows like how many devices, connected devices are out there. So if you look at some of the research, there is a forecast like there will be tens of billions of devices in the next years, but today, already there are more connected devices out there than humans. So this world is already dominated by these interconnected devices and systems. And that's a very interesting world to live in. And you can notice, by the way, that while my role is like to represent Microsoft Azure today, I will mostly not do that. So today I'll try to maybe share my experience and my learning about what I learned about AI in the years which I'm focused on this topic, and share with you some of the demos, show you how this looks, where the technology moves from what I hear, etc. And I will start with this story actually from yesterday. So I was talking with my son. We were buying some water from the vending machine, and he was like, "Father, why do we need to, like, we were giving this money to the machine and it gave us water." And he's like, "Why do we need to earn money? Why can't we just, make machines and robots do all the job, and us humans just getting, the money from the government to spend on what robots produce?" And he was having in mind some of the robots which he saw in some animations. And in the end he said, "But Father," and I said, like, maybe one day it will be like that robots will do all the hard work and we'll just, spend time entertaining ourselves. And he's like, "Yeah, but it's important that it's not those robots, robots with the red eyes," he said. So it's a very interesting also dilemma that the power which we are already bringing with AI into this world, and even the youngest generation, from what they learn from the futuristic animations, for example, they already understand that there is pluses and minuses of this environment, right? And on this slide, I've actually put some of the recent advancements in area of AI coming just from Microsoft. So of course, there are other researchers and other companies, other people who are moving AI, but this is just from Microsoft. Last 5 years, 4.5 years maybe, and you can see that during those last years, our systems, our AI systems, algorithms have reached human parity in object recognition, in translation, in speech recognition, in conversational AI, and even like in understanding what's in the images, etc. So a lot of innovation is happening. And now, let me, by the way, share with you maybe, because it's also like, what is human parity, right? Not everybody understands those terms because it depends on how you measure to the human. And let me show you one of the examples. This is a recording from one of the, by the way, when I was presenting, I'm not sure that I've shared the sound as well. So let me check that and maybe reshare my screen so that we definitely have the sound, because I'll be presenting some sound today. Include computer sound, I was correct. So I'll show with you one of the recordings of the conversations over the phone, which we had in one of the projects to recognize. And it's interesting because when I play this conversation, try to recognize what the person is saying on the phone.
That's about how old ours is.
And by the way, if you can't hear, just let me know. It's important because I will have some demonstration of speech systems today.
Yes, Dima, we can hear you. Thank you.
And you can hear what was played on the slide.
Exactly.
Good. So actually, there are different options here, and I couldn't understand. Like, for the first time I saw this demo, I was trying like 3 times to listen what's there.
That's about how old ours is.
Like, machine can recognize it's that phrase. For me, it was very hard. And that's how we say human parity. If it can recognize or understand or make decisions in the same pretty much error rate as the humans or better, then we say it reached human parity. Now the big question, and this is one of the actual pictures I have proudly stolen from LinkedIn, one of, let's say, colleagues from this industry has shared. like why still, when we have all those robots, all those automated systems, why still humans do the work? And not just any work, but on this picture you can see there are all those robots which can do this cleaning, but still humans for some reason do the cleaning themselves. And one of the reasons is because it's not that easy. Okay, so everybody starts, or many people would present AI as some miracle which looks at as something on the top of this slide. So some people would say, you give it the data, then AI processes it, and immediately you get your, prediction or your value. But that's not how it really works. So really how it works is you need data cleaning, data transformation. You need the data science to engineer features and models and test and train and like fight bias and whatever. And then to get the value, you need to operationalize, you need to build it into existing process. And it's not that easy. And that's pretty much what I do on my work. Day-to-day job is I'm trying to help customers go through this real AI path, which sometimes is not that simple. Now I promised you I will share some thoughts about where the technology is moving, and I've used this similar slide a couple of years ago. Now I would say there are differences. From a couple of years ago, the big thing was NLP, like all the BERT-based models. So right now this thing gone even further, and I will share some of the examples. So language speech processing really exploding. Multi-modal architectures, that's one big change. So since computer vision reached pretty much the level when it's completely usable in most of the scenarios, including the self-driving cars, by the way, which were promised to be everywhere by 2021, didn't happen. But still, the next step was speech language understanding. In multimodal architecture is the new, would say, trend, or the new approach which captures the knowledge from different modes or different domains. For example, we look at the images, we look at the text, and we build a model which understands both, so that it integrates some kind of concepts, it extracts some concepts, not just specific text dependencies or image dependencies, but across domains. So generative networks, of course, automated machine learning when AI is building AI for us. And low-code AI systems is really a big thing, which probably will come in the next years. And let me show some of that to you, because I really want to demonstrate some of those things today. So this on this slide is an image of Spider, and 2015 ImageNet, the architecture on the right. So you saw the animation, like how many layers were in this vision, computer vision model to understand that this is a spider, and how it really works. And I know you had this machine learning session yesterday where you had some of that explanation, but in this case, how deep neural networks work. And in this case, you can literally see it's deep because there are so many layers. But in fact, how it does it, it looks at the one area of the image, then smaller area, then different area, then area with different area. And it just tries to understand statistical dependencies between those different dots on the image. And then just again, based on statistical methods, learn that in most of the spiders, those things sit together, like there's these colors sitting together, representing legs, etc. So now with multimodal models, there are much more complex models which look jointly on a text, and you can see there's a piece of text on the top of the slide where we extract entities like dog and a couch, and it sits. So this kind of language understanding. And at the same time, on the bottom, you can see that we are looking with the same model. We are actually analyzing the image and also extracting that there is a dog and that it sits on the couch. And now we can suddenly have representation from image and from text jointly in one model. And that's very simplified, of course, for you. This is how architecturally it looks. So there is language and image, and both of them actually serve this information into the embedding system, which encodes that, gets trained, and then after the classification, we can decode and we can actually make predictions based on the new images, on new text, on new questions which are asked about that concept. Now, again, these models really explode. So I saw very recently, probably within the last couple of weeks, that Facebook published some breakthrough successes with its model, which can understand different domains and really operate between tasks, which is a completely new concept. So we are used to the things that like image models can recognize images. for like text analytics, you do these text models, right? And here suddenly we have a models which can do many different things. And another model like that recently built, and I just put the image here because I love it. Like this is how many parameters the models have. And you can see that there is this BERT model somewhere 2018, which is what, some 340 billion parameters for BERT large. And then there was this NVIDIA model, huge model, and very recently, actually a year ago, Turing NLG, the big Microsoft model, which has 17.5 billion parameters. So again, the concept is pretty simple. The more parameters you have, the better the performance, in very simplified terms. Now, how to optimize those models, how to use them for different tasks is a different question. Generative networks. So you've all seen probably some funny images, like for example, here on the right, you saw probably the video when Barack Obama, like virtual Barack Obama is actually saying things he would never say. Or on the left here, you can see the image of two people, and those are not actually people. This is just a generated image. This is dots or colors. So those people don't exist. But you can see how much can generative networks how high quality can the output be, right? And with this, there are a lot of challenges because suddenly how our face recognition systems will work, how we will react to these things like fake media, etc. It's a big questions which society still has to address, and researchers as well. And the good news is actually it's a little bit on the dark side when you talk about what fraud can you create with AI, but you can be on a bright side too, right? Because, for example, this is one of the systems which, again, our researchers were working on. This is a system which defines whether the video or image is fake or not. So based on some, again, classification models, it can say that probably this image has been modified, or these news have been modified if you look at the text, and such systems already exist. We have even for the browser, you can install this tool which you just click and you see whether this news is real or not, with some probability, of course. Now I promised you I will show you something. So I wanted to show you some of the examples because some of those things can be just, built. Like you can go in machine learning environment, like in Python notebooks, install all of your dependencies and modules and frameworks and start building your model, train it for a long time. Or like in Microsoft, for example, we have some pre-built models which you can use immediately out of the box. And if you're not a data scientist, a hardcore data scientist, and if you're looking just to leverage this in your applications for yourself or for your organization, this might be a very good way to go. So let me show you some of that, which exists pretty much out of the box and which also represents some of those breakthroughs I was talking about. So hopefully right now you can see my screen with the Visual Studio Code. So this is an application which actually calls one of the cloud AI services, which is called here Speech SDK, or this is actually speech services which can understand speech and transcribe it, or can generate speech. And I first begin with the application because some of you will be building application or coding, and then I will show you how you can actually play with those services and learn how they work even without development. So in this case, we have an application. You can see it, 25 lines, maybe 10 of them are just, clear lines or comments. So it's really just 15 lines of code. And the first couple of lines are just setting the parameters of connecting to my Azure resource. The next one is choosing the language, because I can use different languages here. Probably I'll use Russian in this case. Then I just pass the configuration, which I just did in the first 2 lines, to the service. And then I just run this command, which says speech recognizer. It sends the parameters to the recognizer. Then it says prints to the screen, say something. And then when I say the result has been returned, analyzed, and again printed on the screen. So very simple application. It listens and it prints what it recognizes. So let me run it for you. Добрый день, сейчас я буду говорить по-русски и увидим, как система это распознает. So this was pretty much, I don't know how many of you speak Russian, but we can try English as well. You can see that the quality is very high. The system just recognized everything. But I just wanted to show you how simple is it for you if you're a developer in any kind of Python, JavaScript, Java, like C# or any other application development framework. You can actually use those services, calling just, one API and getting your results out of there. Now let me show you the same thing, but from the web portal. So again, if you go to Microsoft, you can just search online for speech services from Microsoft, and you can go to this portal, which allows you to demo or to play or to understand how those systems work. And you can see different capabilities here. We won't have time to go through all of them. I just wanted to show you some of them. And one of them is, again, real-time speech to text. So the same problem. Let me say something and see how it's been recognized. So you can see I clicked probably too fast. So actually it recognized almost clearly. Now I can show you, so you can of course choose different languages, and you can see there are many languages. For example, I can choose Czech. I also speak some Czech. I lived for 6 years, for the 6 last years. I'm from Ukraine, but living in Czech Republic for six years. So let me try something, how good my Czech is. Dobrý den, dnes promluvíme o umělé inteligenci. And it actually recognized, so my Czech is not that bad. So you can play with it yourself. And just, again, if you build an application which needs to, like a speech bot or something which just recognizes speech, it's a perfect system for you just not to build the model from scratch, but build it based on those APIs. Now you can even customize those things. For example, you can customize specific language for, I don't know, healthcare, like drugs, etc. You can add the dictionary so it starts to recognize specific terms or specific names of the products, etc. You can also build systems, and it's, I think, a super cool stuff. So you can also build systems which make text and generate speech. And there are a lot of applications now. So we work with large telcos to build the voice bots. We work with some other companies which just, make announcements. Some of the companies, like video creative software, just allows you to write. You have a video, you write the text, and it will be the text will be spoken over the video. You don't need to hire an actor who would speak, And you can even make it a custom voice. So I can make it generate speech in my voice or in the voice of, I don't know, the president of, Ukraine or any person, which is, of course, a power, but a problem as well. Let me show you how it works, because I think it's super powerful. So let me probably create a new file here, and we can write whatever we want. For example, I'll write something interesting like, hello, I'm calling you from the bank. Your card is blocked. Can you please share your PIN? Right, so something like that, which somebody can use, and attach this to the phone call. Maybe make it sound like your bank person which you know, and just do it. And let me generate speech from this.
Hello, I'm calling you from the bank. Your card is blocked. Can you please share your PIN?
And you can choose different pre-built voices. It can speak as a man.
Hello, I'm calling you from the bank. Your card is blocked.
And etc. So again, you can make it even a custom, like look like a real person and sound like a real person. You can choose actually very different pronunciations. You can make it faster. You can make it more emotional. So a lot of capabilities to fine tune that. But it is why I'm showing this to you, because that's really scary, like how those systems evolve. It means that in the nearest futures or today, if somebody is calling you, or if some video which you are watching, or some sound recording you are watching, there is no guarantee that it's been real, it's been spoken by that person, or generated this video of that person, etc. And that's why, for example, if we talk about the custom voice, so we work with, again, some of the telcos who hire an actor, and this voice will speak with the voice of this actor. Every time the customer is building something with custom voice in this system, we actually approve that. So the customer needs to write us why and how they will use it, and we will have to review that and approve that, and only then they can use that, because you can imagine how many misuse scenarios are available, not just with this system, but any system like that. So the power of the system is so powerful now that we need to be careful, not of what it can do, but as we say, like what it should do or should not do. So this was one of the demos. I'm not seeing any of the IM, so if there is something urgent I need to address, please let me know. If not, I'm continuing. Quiet, so I'll go. Sorry. So I'll click through some of those slides because I've just shown it. And one of the models which represents those new powerful generation of models is OpenAI GPT-3. And I don't know how many of you know what is OpenAI and what is GPT-3. But that's a super powerful model, which really, again, it was a breakthrough when everybody suddenly saw what can AI do in real life applications. And one of those, it's actually a screenshot from last week. This is, maybe even from this weekend. One of, again, the colleagues who is working in this area shared, he got approved to play with the demo or with the API from OpenAI GPT-3. And he played with it. And what he did is he asked AI, can you tell me a joke? And I will tell you a joke, and they will like discussing with AI about their jokes. And he published this conversation on LinkedIn, and he asked for people to actually rate which joke was better. And you can see that in the end, actually OpenGPT-3 won. So that's, from my perspective, one thing we should understand, that this thing can already make fun or joke better than humans, right? And one of the real like fun side, one of the real applications of that is, because this is a multi-modal models or set of models which can make summarization of the text. It can answer questions. And in this case, this is summarization. And you can see one of the companies, Yabble, they actually use this for, they have reviews, like reviews for the products, reviews for the hotel rooms, whatever you can analyze. So there are reviews, and in each review, like somebody saying, hey, beach was far, or I didn't like the cleanliness, etc. But then this system can look under all reviews, not 5, 10, 100 reviews, all of the reviews, and just give you a summary that the most common activities that people enjoy are, and what they hate is. So exactly like you get the insight from all of that richness of the information pretty much immediately using those summarization methods in those models. And this is just one of the applications. And why I'm talking about OpenAI, it's not necessarily Microsoft, but OpenAI in June 2020 released this API publicly. And then we have announced there were different developments of that, which, by the way, I will show to you in a moment. For example, it can now generate code. So if you're writing a code, you can just make a comment and I'll show you how it works, and it can generate code for you. But recently, just in November 2021, so 1 month ago, we have announced from Azure, from our cloud, from Microsoft, you can actually, and enterprise customers can subscribe and get this service and like as a usual paid service in our portfolio. So they can subscribe, they can get use of this model, use it from the cloud, no need to redevelop this whole huge model, and use it from anywhere, because again, this is a global cloud offering. Which gets me to the next slide, which is like, I promised not to talk much about Microsoft today, but I work for Microsoft and I can show you one of the cloud vendors, which is probably one of the leading AI players on the market, what we have in our portfolio. And if you look at the different players on the market, the big cloud vendors, it will be a similar portfolio. But for us, it's actually based on one platform offering, which is called Azure Machine Learning. And that's actually a cloud platform which enables you to get resources in the cloud to automate your machine learning production and use some advanced capabilities. We might touch on this today. Then there are cognitive services. This is APIs for developers, for data scientists, which they can call from the cloud. No need to redevelop it from scratch. Maybe fine-tune that as with custom vision models, for example. You can get the model as is, then fine-tune yourself if you want, or with speech again, you can make it customized and then use it. So this is pretty much a pre-built, very powerful and customizable models. And then on top of that, we have some offerings which are more like for the use cases. For example, I'll show you today what is forms recognizer and how it can be used. There is like analyzing video, again, using the cognitive services. There are applied services built for some use cases like analyzing video or analyzing forms or building a bot, etc. So this is pretty much what we offer. We don't offer as Microsoft like we don't replace something which you want to build in your project, but we give you those tools and those services which you can reuse in your projects, and I think some of them are very powerful. So here is a demo which I wanted also just to run a video for 2 minutes of one of our sessions a couple of weeks ago on Ignite event about how this Open AI's GPT-3 model generates code. Let me just run it for you.
Code that will power a non-player character in Minecraft. Thus far, I have a prompt that is composed of a basic JavaScript comment explaining that the following is going to be a series of commands and the needed to push them using a specific library. Now, I'll start by giving a command here, go forward, and I'll preface this by saying that the model has never actually seen the library. So even though it generated code that looks reasonable, this isn't code that would actually execute in the MindSlayer library. So let's give it the code it should have written. Set control state forward to true. And now I'll ask it to go backwards. And sure enough, it now produced the correct code using the spot.setControls function, and it correctly guessed that it should pass back as a parameter instead of forward to move in a different direction. Now let's see if by giving it a more complex example, telling it to jump a few times, we can generalize to more complex behavior. So now I'll say move left a bit. And it's produced several lines of code that actually correctly guess how to move left some amount of time. It saw from our example using the timeout method that this is how we handle something temporal. It interpreted a few times as 1,000 milliseconds, and here it interpreted a bit as 1,000 milliseconds as well. I'll show one more example. I'm going to say now write longer. And sure enough, it produced the correct code here, and we can see that it interpreted for longer as 2,000 milliseconds. This also demonstrates that we can carry context throughout our interaction with the NPC to know what to do based on context from earlier in the conversation. Now I'll move over to Minecraft to show this in action. I'm now in Minecraft and accompanied by my non-player character named Boopbot. We've continued to build on top of that prompt and given several more examples of the kind of code it can generate to enable new behaviors. I'll start by showing some of the behaviors we showed in the last demo. I'll say, move left a bit. And you can see it generated that same code. I'll say, now write for longer. And we're echoing the code down here in the chat. And you can see that it now interpreted for longer as 2,000 milliseconds instead of the 1,000 seconds and correctly moved right. I'll say jump a bit. And it's 1 second. And I'll say, what directions have you moved? Codex is capable of generating not just code, but also natural language. And in this case, it responded with a dialogue, I've moved left, right, and jumped. So Codex can generate code, natural language, and in this case, it's even generating natural language about the code that it generated. Now, we've enabled several complex behaviors just by prompt engineering. I'll show one of those. I'm going to ask it, how do I make a crafting table? Which is a very important resource in Minecraft. And it was able to reason over some structured data that was in its prompt to answer, you need 4 oak logs to make a crafting table. Now I'll say, now get those for me. And it's generated some more complex code here, several lines of code, to go mine those 4 blocks, come over to the player, and say, I got your oak logs. So just by generating prompts, just by showing examples of how we can use an API or a library, we're able to generate novel code that handles new behaviors that we never actually showed the model.
So this is kind of the applications which I think in the future, the nearest future, will really change how people write code. And one of the examples is GitHub Copilot. This is one of the systems which is enabled by this same model, which allows you to write code in different programming languages. And you can see here again on the GIF that you can just write in a natural language what you want to achieve, and the system will suggest you a real multi-line code with iterations, etc., which you can just fine-tune then and go on. And this actually is trained based on the millions and millions of open, like freely available GitHub repos. So that, and what it actually does, so instead of like searching on Stack Overflow, like how this task can be done, you just type it and you immediately get the best suggestion from the people who already solved it. And this, by the way, is been already integrated in some of the systems. For example, I don't know if you had some discovered in some other sessions already on this summit, because, for example, it is enabled in Power BI. So you can today say, show me rolling 10-day average or some other commands which you can give to Power BI, and it actually will understand, translate it in specific DAX expression and just get you that result and even build this visual for you based on your natural language query. Or the same works is actually in Power Platform. So if you want to use it in Power Automate, etc., you can just, type again in natural language, and Copilot system will actually provide the formulas for you, which you can reuse and then modify. So super, super powerful applications. I'm just giving you a sneak peek, have no time to really show you in depth, but I think that's what we need to watch, like what those systems are capable today and where they are moving is just unbelievable. So with this, let me also show you a couple of other examples. And I will go a little bit deeper in some of the services which we provide from Azure as APIs which you can use in your applications. And those include different systems around vision. For example, we can detect faces, we can do form recognition or ink recognition when there is handwritten text. We can work with videos and find people where they speak, where they appear in the video, transcribe text specifically from this person in the video, etc. We can do computer vision tasks, and I will show some of them. We can do, again, speaker recognition, speech generation, language understanding. There are some anomaly detection or personalizer systems which enable you to build systems for personalized services, and a lot of web search or cognitive search capabilities as well. So just to show you an example of one of the clouds, like Azure Cloud, it offers already a richness of the models which you pretty much don't need to rebuild, or you of course can build it, but you can also use some of them to prototype or just to solve your task for your application. Now this is one of the examples for Video Analyzer. This is a service, and again, we call it an apply service. It's on the top of the architecture or platform view which I was showing. So it's really a service which helps solve applied tasks. So not just it understands what's in the image. It helps you get the video, then get it processed, get it transformed in a way that the machine learning model can work with that. Train your model, apply this model, deploy this model, always in one service. If you see people on this, in the airport, you can blur their faces if you want to save the privacy. And this is one of the examples. There's such a company called Zero-G. They built this solution for Lufthansa, which actually, I'll probably run this video also while I'm speaking. So it actually analyzes, it's probably very small on your screen, but it analyzes the arrival of the airplane, arrival and departure, what they call a turnaround. And why it's important is because this turnaround event is a very complex event. It's hundreds of events happening actually. The plane has landed, the plane has taxied to the position. It has been, the doors were unlocked, the fueling machine came, people left, luggage left, luggage transferred, etc. Cleaning started, and all of those processes need to be completed in a very defined time scales. And if you miss some of that, then the flight can be delayed. There are security risks if something goes wrong, for example, with the maintenance, or there is not enough time for maintenance. Huge security and safety risks, and a lot of just financial implications, because again, if you miss the deadline, the flight is delayed. Lufthansa simply has to pay for the passengers for delayed flights. So that's one of the applications. There are many more. For example, in this same video system, by the way, this is another video, I think, in a bigger resolution. I forgot that I have it here as well. So you can see it recognizes people, fueling machine, cleaning machine, and really puts this on a time scale. So this is a very powerful application, of course, not just for airlines, but one of the examples where those systems for video or image analytics, even without building them from scratch, can be used today in real production scenarios. So if you will be working on some of the projects which needs to analyze videos, really look into this service. It might be very helpful. This is another application of the same video analytics system, but this time we count people in the store. We count actually what was the distance on specific time, and we can say maybe in this place it's too narrow and people get too close. So in COVID times, maybe we need to just make it broader, etc. Where the people spend more time near which shelf. So we can do all kinds of analysis here. Or maybe this different system, which we are building in Poland now for one of the customers. There are pills which have been produced, and those pills are moving on production lines, and somebody needs to remove the pills which are broken or have some defects in it. And of course, for humans to look at every pill, it's really, really time consuming. People get tired, people may not notice things, and we build this system which can analyze this at speed and really look at every pill which is passing and just remove those defect ones. So super, super powerful, beneficial project for the customer. And again, using live video analytics, many of the tasks which every other customer would solve here, like how I capture the video, how I process the video, how I get images from this video extracted, how I analyze those videos, how I send results, all of that is kind of packaged, which is much easier to leverage. Another powerful services which can be built by yourself, or in this case, which are pre-built in our Forms Recognizer service, is understanding the text. It might be handwritten or printed text in PDFs and images and scans and whatever, and getting the information extracted. And in this case, you can see it extracted the pairs of keys and values. For example, quarter ended this date, transition period this date. So everything which was here, similar to the tables, like if you have, ID, it extracts that this is how this ID is named and this is the actual ID. So this is already used by many customers. For example, here in Czech Republic, when the government distributes help for people due to COVID limitations, due to lockdown, what they used, they actually used the system which looks at the ID of the citizen and extracts immediately. Like you can remotely, not go into your ministry or to some government organization, but just during the lockdown, how you submit those claims, you just remotely send your documents and you make a video or an image of your ID, and it just extracts your data from that. So you don't need actually to go somewhere, or nobody in the government service doesn't need to transcribe what's written on your ID. The system does that automatically. And I thought again that maybe I'd better show this to you. This is Forms Recognizer Studio, so a very similar experience to what we did with speech. You can actually go here and play with the system, like you can recognize business cards. And again, I will remind you, it doesn't mean you have to always use it through this portal. This portal just calls an API, so you can definitely call it from your application or from your mobile application or website or whatever. In this case, it's just easier to show how it works and to play and to test whether it's something what you want. And let me show you some of that. For example, here is some document which is loaded. And if I press Analyze, you can also see there is many tables, very different formatted tables. And here is the JSON response which it actually extracted. You can see that there is the borders of the table and specific values within the table. So you can actually parse this JSON and look at the table here. It also generates an actual code. So for example, in this case, I think that's Python. So you can actually just, it's Python, but you can in some cases generate different code. So you can here just copy paste this code and to use the same system in your application. Or if I go here for the general documents, you can see you can also look at some contracts. And as an example, let me take one of my own documents. So this is again one of the documents issued by the government for my medical insurance. And for security reasons, I actually replaced some of the numbers here. So it's not my actual medical insurance number. But let me see if it can recognize that. And you can see it's not anymore that clear document, which is scanned perfectly. It's actually page which I made a photo with my mobile. Not very good quality, not very good lighting. And let's see if it understands that. So I'll hit analyze. And now it calls the service, sends the image, and gets back the results. Let's see what it recognizes. And it takes so long for some reason. Very weird. Shouldn't be like that. My medical insurance is a very complex document, probably. Come on. There is something wrong now. Maybe my connection, I don't know. Let me try it again. Oh, it was probably a problem with displaying. Okay, something with my browser. I'll probably need to reload it at some point so that it starts to represent it correctly. Because you can see when I add the document, it already shows the result, but when I start to run it again, it just gets crazy. Come on. Yeah, there is something with my connection probably. So last try, and if it doesn't work, we'll just move on. This is the problem with any demo heavy presentation. So every time I demo something, there might be challenges. I don't know what's your experience, but for me, it's usually like that. No demo goes without challenges, always.
We had in the mornings issues with some other people demos, so yeah, we know that.
No, but that's normal. I mean, sometimes the connection is broken. I have not very stable internet at my home, etc. But you can see now it works. So you can see not just what it recognized, but also where exactly, right? So you can see by the color coding, like here was the date. And by the way, this particular document is in Czech language. So it recognized that the language is Czech. It OCR'd the name of the pair and the actual surname, name, data, whatever data is there. And I can actually even train this model further. So you can see the confidence scores. If something I don't like or it didn't recognize correctly, I can even fine-tune. So there is additional capabilities in this studio that I can fine-tune my model, say, no, here is my date, not here, and the system will learn further. I can see the result in JSON as well. And I can see the actual code again. I just copy paste it now in my application in Python, just load any image or load image from my mobile camera, and it will start recognizing that out of the box. So a super powerful system, especially when there is this problem of analyzing many documents, forms, invoices, whatever. So any kind of document which has the information which needs to be extracted can be processed with that. So let me move on. There is additional things which I wanted to show you, and maybe before I do that, because I don't remember which slides go after which, but let me probably also switch back to one more demo. Or maybe let me talk for a couple of minutes about Azure Machine Learning. So Azure Machine Learning is a platform which allows the data scientists, not really the developers, but the data scientists to build models, right? Right now, we just saw how you can use APIs or powerful models which we have from the cloud. But now if you are building them as a data scientist, or you build in some scenarios like predictive maintenance, analyzing fraud, doing some recommendation systems or demand forecasting, very, very popular scenarios where you need to work with data and build machine learning models yourself. Then we have Azure Machine Learning Studio and Azure Machine Learning Platform, which allows you to build those models and to use some of the state-of-the-art capabilities. Like, for example, again, I'll probably show that to you. It will be easier. So if I go now to ml.azure.com, this is my environment for Azure Machine Learning. So this is a platform which really automates end-to-end work on your machine learning. For example, you have notebooks here which you can run in the cloud. You have automated ML. For example, there is some systems which I was running so that the system builds machine learning models for me, which I then can fine-tune, for example, for forecasting. We have examples here. We have Designer, which is a drag and drop system, which allows you to really, if you're not a developer, but you rather prefer like to get together those architectures in boxes, drag some arrows between and make them connected and really see how it works, or you want to get the model which exists and just look at how it's structured on this architectural view, then Designer is for you. Then you have data sets, experiments, you have pipelines which can be retrained every time the data changes, for example. You have your models, you can deploy them to different endpoints, and of course you have compute, like you can connect it on a regular CPU machine in the cloud. You can connect it on a very large cluster, distributed cluster, for example, on GPUs, etc. I will not spend a lot of time today on this, but I'll probably just click on one of the experiments for automated ML and show you one more thing. Because every time you build machine learning models, you need to see, first of all, how your machine learning development worked, but also sometimes you need to understand like how it makes decisions, or like, is my data correct? Is my decision correct? And that's where, for example, this is finished experiment for AutoML, which generated some models. I can see those models here on the chart. I can see their performance, like how long it has been trained, what is the mean squared error, what is like the accuracy scores. I can click on the particular model. And for example, for this model, I can look at actual model and deploy it. I can see its parameters, and I can even view explanation. So there is a very powerful toolkit which you can use outside of Azure Machine Learning and right from within the Azure Machine Learning. And in this case, for example, for my forecasting system, I can see, for example, which parameters influenced the system decisions. So you can see that my weather forecasting, or it was heat energy consumption for heating system forecasting. So you can see what influenced the most the prediction. For example, the hour of the day and the temperature outside were the two most important features. And there are many more analysis which you can do with this toolkit. Like you can look at individual predictions, why they were made, etc. You can look at the data set and explore how balanced it is. So all kinds of explorations, because we believe that, back to this question with robots with red eyes, that every time you build, I'll click through this, every time you build something with AI, you should build it responsibly, right? And before I go to the closing slides, let me switch back to one more demo. This will be the last one, but I think it's even more fun. So this is called Language Studio. So remember, I showed you today how to work with the speech API, how to use forms recognizer. Now you can play also with the really state-of-the-art models for language understanding. And this is why I'm saying state-of-the-art, because it really, for me, it's really impressive how those core fundamental research systems or new algorithms transform into real products. Like we announced these new multi-language models pretty recently, and now they're here. Like, for example, our translation, our language model now doesn't just work in one language. It's trained in all languages at the same time, and translation system, etc. And what we achieved is actually with this unified language model, we can even do different tasks. So we can answer questions, extract entities, translate, all within one model. So those models become extremely capable. Let me show you this new generation of models in action. For example, I've actually opened a couple of CNN articles from today just for the demo. For example, this article about the new chancellor in Germany. And let me take this text and give it to the system. And what can we do with it? We can, for example, extract key phrases from this, right? So we can say, here it is, it's English. And let me run this extraction. And the system will extract key phrases. You can see they're highlighted here, like people, entities, key phrases, which make importance, and like to get you summarized view, or maybe to search through this information, a very fast result. So what else can we do with that? Let me probably do, what can I do with that? Let me do, for example, sentiment analysis. So let me add this text. Again, select English in this demo. and run and see, well, sentiment is this positive, is it negative, is it neutral? And we can even look at individual sentences. So in this case, we can see that this is, we can see that this is somehow recognized pretty much half-half, positive, negative, a little bit more negative. We can see that individual sentences, for example, this first sentence is neutral, the second is neutral, and then there will be some sentence probably which is very negative. So if you're analyzing the information from internet, from your customer calls, from whatever conversations you analyze, you can, here is the sentence which it recognized that it's negative, for example, that there are some party tensions, etc. So we can see that it helps us get the sentiment from different sentences and really make decisions on where we can put attention. This is another article which speaks about the blocking of the Olympic Games, not blocking, but of the English word, sorry. Boycott of the Olympic Games by some countries, and of course this should be a negative article, right? If you are analyzing some text like that, it's 73% negative, and again we can look where exactly the negativity is in this text. But even more powerful, let me do the following. Let me come back to this example of the new chancellor, and let me analyze with this model. Let me analyze this text and make it answer the questions. So for example, again, I choose English here, and you can see it can work in many, many languages. So let me analyze the text and let me ask the question. So this was a text about new chancellor instead of Angela Merkel, appointed in Germany. And let's imagine, I need to understand what's the essence of all the news articles without reading all of them. Or I need to answer some questions. Let me ask the question, for example, who is the new chancellor? I hope I correctly type it. And you can see the long answer which it provided. It summarized the answer. You can see that it actually got the answer that following the ceremonial protocol, Scholz went to see German president and he was officially appointed. Or you can even build a system which will answer immediately like what human would answer, right? So who is the new chancellor? Frank-Walter Steinmeier. So very, very fast, quickly. By the way, is it correct? Okay. Should be Olaf Scholz. No? Interesting. So the short answer was incorrect in this case. So let me ask something else. For example, what happened to Merkel? Let me see if this time it will be as correct as humans would. So her term came to an end, and it also says that Scholz was voted as Germany's new chancellor. This time it's a correct answer, and you can see again, you can get the long answer, you can get a very short direct answer from this system. And also if you build in some kind of summarization systems or analytic systems which analyze the news, this is one of the powerful applications of those systems. So now I'm pretty much on time. I have 4 minutes left, and I just wanted to leave you with one show this one. So I just wanted to leave you with one slide, which you can download after the session. And this is what I give to you, because I cannot show you what's possible in 1 hour, but I can give you the links to 2 specific learning journeys. And we have a very large, very big, very comprehensive learning journeys, but these ones are very narrow, very focused, and it promises that in 4 weeks, if you want to learn what's possible with Azure AI, pretty much so that you are confidently using those services in your applications, within 4 weeks, spending 1 or 2 hours a day, you can learn it if you go through this Azure AI 0 to hero in 4 weeks learning journey. Or the same with machine learning. If you don't just want to use all the cognitive services and all the APIs, you're really a data scientist, then you can click on this one and go and learn all what is related to data science, machine learning, plus how you can do it in Azure within 4 weeks, again, spending 1 or 2 hours a day, really learn that. So this is my give away to you. Just use it, set up 30 days, focus on it, spend at least an hour a day, and you can really learn those things from those resources. With this, I'm closing just with some thinking how I think about AI, because I know many people say AI is. So for me, AI is a technology really, which allows people and organizations to achieve more. So there are many definitions, but in the end, it's up to you about what beautiful application you will build based on that. And I really encourage you to look into what's possible, because those applications can be pretty powerful, as you can see today.